and in this edition of Easy as Pie, I will be walking you through the linear functions and inequalities review. So if you were not here to work on it, or you did work on it and you just want some clarification on an answer, or maybe you just want some different strategies to go through these kinds of problems, then this is the video for you. So this is the answer key, and I will turn that thickness down a notch. Number one, which relation is a function? When we're thinking about which relation is a function, our main question is which of these scenarios are going to have one output for every input, right? So every time I input something, I should only ever be getting one output, right? So for example, we know for certain that it cannot be A, because if I input a parent, there's a chance that parent has more than one child, right? So if the input is my mother, then the output could be me. The output could also be several of my brothers, right? So there's more than one output for every input. Same thing for letter B. If I input third base, I could get Josh Jung. I could get Eduardo Escobar. I could get a lot of people who play that position in baseball. And same thing for letter C. Although it's a little more innocuous, right? There are lots of holidays that maybe you don't celebrate that still occur on the same day. Maybe different religious observances, or maybe just like give your best friend a hug day, right? Would be considered a holiday, right? The point is, one day can have multiple holidays. The only one that we could really consider a function would be letter D, right? Because every student gets one birthday, right? So one input has one output. And if it's which relation is not a function, which could happen on the test as well, this is, could be, and is not. In which case, you're just looking at the reverse, right? Which one could I reasonably see more than one output for every input? Moving on, number two. This is a quadratic function. Don't let it scare you. We're just finding the inverse function, right? When you see that little f to the -1, you're thinking of inverse functions. And our strategy for making an inverse function is the same no matter what the type of function is, right? I'm going to start by just rewriting this as a y instead of an f of x. So it's a letter that I can manipulate. It's a variable. And then the x and the y switch places. So instead of y equals 4x, it is x equals 4y minus 5 squared minus 2. And at this point, I just have to solve for y, right? I can't deal with the squared until its whole base is by itself in the equation. So this minus 2 on the end is my first plane of attack. I have to subtract 2, or I have to add 2, my apologies, to both sides. So x plus 2 equals 4 minus y minus 5 squared. And now notice the base of this exponent is now by itself on the right-hand side. So now, and only now, do I get the liberty of taking the square root of both sides. Right, and I do this because the square root is the opposite of squaring. So, following that logic, we have the square root of x plus 2 equals 4y minus 5. Now the square's gone. And from this point, it is our regular equation solving skills that we know and love, right? I can add 5 to both sides. I'll move over here. The square root of x plus 2. Remember that plus 5 does not go inside the square root. It is not invited to the party. It has to stay on the outside. Equals 4y. And then I just have to divide by 4 to cancel out that last variable. And this is what we're going to get as our answer. The square root of x plus 2 plus 5 divided by 4. Right? The answer looks a little overwhelming at first glance, right? But if we just take it one step at a time, we're going to get ourselves to that right answer. And you can always graph this answer, and you can graph that function, and they should look like a mirror image of each other across the line y equals x. So if you draw this line right here, right, they should be reflecting off of that line. And that's what your inverse is going to look like. Number 3, consider the function which statement is true. This is looking at our slopes and our y-intercepts, and in order to really decipher those, we need to be in the form y equals mx plus b, right? So y needs to be by itself. So once again, we have to take some steps to get y by itself. Thankfully, not as much of a hassle as last time. I can just subtract 5 and 4y equals, these are not like terms, these two, so do not combine them. It is just 7x minus 5. And then we have to divide every term by 4, right? And don't get so caught up with the fact that there's gross fractions, right? Gross fractions are going to happen in Algebra 2. It's just about finding a way to live with them and be comfortable with writing fractions as coefficients, right? So y equals 7 over 4x minus 5 over 4, right? There's no reason to write out their decimals because the 7 over 4 is going to turn into a repeating decimal, right? And there's really no way to quantify that into a decimal that's going to make sense on your function. So just leave it as 7 over 4. And it's at this point that you probably realize there's a typo in the answers, right? Because none of these are right. You pull this out right here. 7 over 4 is that is the slope. And negative 5 over 4 is the y-intercept, right? Because this is in that form mx plus b, where m is my slope and b is my y-intercept, right? So if you were in class, I would have made this little change right here to change the y-intercept to be negative 5 over 4 so that you could select C as your answer. But if you were not in class and you just jumped into the review, you probably were a little confused. So my apologies on that. Number 4, we're looking for a solution to an inequality. Remember, when we are solving inequalities, our process is the exact same as when we are solving equations. The only difference is that rule where we divide by a negative number, we have to flip the inequality. That does not occur here, but we do have another lesser known equation solving strategy that we use, right? Canceling out the squares. Same thing as up here, right? Canceling out a square requires us to do the square root. And since the base of this exponent, once again, is by itself on the inequality, that gives me the liberty to be able to take a square root comfortably. Once again, you can technically do it with other stuff, but you have to be very careful. And most students end up making mistakes. So square root, both sides. Those we're going to cancel out, and I'll get x plus 3 is greater than, and the square root of 16 is 4, because 4 times 4 is 16. Then we're one step away. Take away 3 from both sides. And x is greater than 1. And that's how we get that answer, right? And if we were in a situation where it was 2x, negative 2x is greater than 1, right? And I'd have to divide by negative 2, I have to remember to flip my inequality. So that greater than is going to turn into a less than, right? That is the only rule that we have to keep in mind when we're solving our inequalities, right? If there are no dividing by negatives or multiplying by negatives, for that matter, then we're going to have the same situation every time. Number 5, identify whether the following relations are a function or not. If you have a graph, then the vertical line test is going to be your best friend. If you can ever draw a vertical line through a function and it crosses the function at more than one point, then that is not a function, right? Because at that input, right, there are multiple outputs, right? And that disqualifies you for being a function. Over here, if I have a collection of ordered pairs, right, a relation, then I can look at every ordered pair and ensure that one input corresponds to exactly one output, right? In this case, I should not have things like this, where the input 4 corresponds to an output of 5, but it also corresponds to an output of 10, right? If I input 4, I don't know if I'm going to get 5 or 10 from it. So for that reason, this is also not a function. Okay. Down here, f of x equals x plus 1. This is a perfect example of just a linear function in the form y equals mx plus b. So yes, this counts as a function. And then for here, every vertical line that I draw only seems to cross the function once. So all of these inputs are only going to have one output, and for that reason, this is also a function. Right? So as long as you understand the vertical line test as well as understanding what a function is defined by, one input for every output, right? Every person gets one birthday, then you should be fine on those questions. Number 6, once again, we're looking at pulling slope and y-intercept from a function. So mx plus b, where m is the slope and b is the y-intercept, right? And of course, for y, I could have f of x or g of x or h of x or really any letter of x in place of that. So that way we're able to use function notation. So don't be thrown off by h of x. You can just kind of pretend that it's a y if you want. So in identifying the slope, well, this would be my m, and that would be my b. So my slope is -2. And if you want, you can write -2/1 for that rise over run look. And for my y-intercept, which is always written as a coordinate, it would be 0, 2, right? When the input is 0, the output is 2, and that is where it'll cross the y-axis. What is h of 8? Right, so this is h of x. So if I want to know h of 8, all that means is I have to plug in an 8 every time I see an x, right? What is the output when the input is 8? So I would define h of 8 as -2 times, there's x. So I would just put in 8 plus 2. -2 times 8 is -16, and -16 plus 2 is -14. So h of 8 would be -14. If you want a coordinate, right, that'd be 8, -14. That's my input, and that's my output. Then we get h of x plus 1. Don't be scared by the fact that there is a variable inside of the function notation, inside of the input, right? Your process is not going to change. H of x plus 1. Now, every time I see my letter x, I'm going to plug in an x plus 1, right? So -2 times parentheses x plus 1 plus 2. And at this point, right, we're not going to get a physical number for our answer, right? Because we have two variables. One equation with two variables means we're not able to solve for anything. So you should not try to magically erase a variable to get yourself an answer, right? Your goal is just to simplify as much as you can, right? So we can distribute. -2 times x is -2x. And -2 times +1 is -2. And that carry down to +2. And then I just get to combine like terms. So -2x and -2 plus 2, those are going to cancel out. And that's my final answer. Okay? So don't be psyched out by this. It is the same process as that. It's just your answer is going to be represented with a variable in terms of x. Consider the function f of x. Once again, we can think of it as y equals -10x minus 12. Finding the inverse. Same process as in that multiple choice question. My y and my x are going to flip places. Because in my inverse function, my outputs become my inputs, and my inputs become my outputs. So x equals -10 y minus 12. Okay, and now we are solving for y, right? Everything on the right-hand side that's along with the y is currently a problem. So I have to fix both the multiply by -10 and the subtracting of 12. So subtract 12, that means I will add 12 to both sides. X plus 12 equals -10y. And then the opposite of multiplying by -10 is dividing by -10. Those will cancel. And we will get y equals x plus 12 over negative 10. And we're finding f inverse of x. So at the end of the day, I'm going to take that y and I'm going to put it back into its inverse function form. And this is where I can stop, right? I have found my inverse function. Number 8, we are graphing a compound inequality. We are going to take this one step at a time, which means we'll start by graphing this one, and then we'll move on and we'll graph this other one, and I'll put them in their own respective colors. For both of them, I have to take extra measures to isolate my variable, right? Because when you're going to put this in your graphing calculator, it's not going to allow you to put it in if y is not by itself. And in this case, 2y is greater than 3x minus 6. Y is not by itself. So we have to take that extra step and divide everything by 2 because I want y to be by itself, but it's being multiplied by 2. So that cancels. Y is greater than, we divided by a positive number, so I'm not going to flip by inequality. 3 over 2x minus, and 6 divided by 2 is 3. Okay. And let's go ahead and isolate the other one as well for y. So that way we can focus all of our attention on graphing. So we got negative 6y minus 6 is less than 12x. Okay. So everything on the same side as the y is a problem. So this minus 6 is a problem. So I have to add 6 to both sides. And we're going to get negative 6y is less than 12x plus 6. And then the multiply by negative 6 is a problem. So I'm going to have to divide by negative 6. And notice now that I have divided by a negative number. So that less than sign is going to be a greater than sign. Please take great care to make sure that you're not forgetting that rule in case you have to apply it, right? Because it's going to be seldom that you have to use the rule, which unfortunately makes it easier to forget. 12 divided by negative 6 is negative 2 times x, and 6 divided by negative 6 is negative 1. Great, now we are all good to graph. I'll start with the blue one. So, y is greater than 3 over 2x minus 3. Let's just take a second and pretend that it was an equal sign and get the line, and then we'll figure out the rest, right? For you, right, if you're comfortable putting both of these into your calculator and finding your 2 points that lie in the crosshairs, plotting them, and then drawing your ruler through, right, then at this point, you would be good to do that. I don't have my graphing calculator able to show you, so I'm just going to do it the old-fashioned way, right? As a y-intercept of negative 3. So I definitely know the point 0, comma, negative 3 is there. And then the slope is 3 over 2. So I'm rising 3 and I'm running 2. Rise 3, run 2, right? I go up 3 and then I go right 2. Now I have my 2 points. It's a greater than symbol, not a greater than or equal to. So this is going to be a dotted line. And it's going to be a poorly drawn dotted line because my ruler capabilities are kind of shoddy on this iPad. But I'll do my best. You guys will all have rulers on your test, so that will be no concern to you. I draw my arrows. Do not forget your arrows. And once I'm done shading, I will label in that stuff at the end. And that's the shading, right? Shading is going to be greater than 3 over 2x minus 3. So everything above this line. And once again, this is not something that you have to guess, right? You will have your graphing calculator available to you, and it will show you this shading for you. So you will not have to guess this by any means. Now I can graph the green equation. It has the y-intercept of negative 1. So I know for certain the point 0, comma, negative 1 is going to be there. And then it has a slope of negative 2 over 1. So I am going down 2 and right 1. Scroll down a little bit. Down 2, right 1. Down 2, right 1. Okay, and now I have another line that I can draw. Dotted, of course, because it's a strictly greater than. Put in some arrows. And now I shade. Once again, everything bigger than this line. So I know that's going to be everything above it. Now, what's my solution set? This is the only part where you have to pay attention to this word here, right? It's an and, right? In order for this and that to be true, right, both conditions have to be satisfied. If I go to the store, if I claim that I go to the store and I buy oranges, but I only went to the store, my claim is not true, right? I have to do both things. In this inequality, both the blue and the green shadings have to be satisfied, which means this area right here where both blue and green are shaded would be my solution set. Now, really quick before I close off, as an aside, if this was an or statement, which it definitely could be an or statement, right, then everything that is shaded would be the solution set. And you can just draw multiple S's if you have to, right? Because if I say I go to the store or I buy oranges, then I only have to do one of them. And in my inequality, only one of the shaded areas has to be met in order for the statement to be true. So keep that in mind as you study. Please do not hesitate to email me if you have any questions. Thank you.